Hello and welcome to our project PhishGuard AI. My name is Mohammed and I'm here to start the presentation with my team. You can go to the next slide, please. Our team is Ali Hassan Khan, Tejinder, myself, Mohammed, and Eduvu. And we worked on this project called PhishGuard ID. The main idea is we wanted to make a application that would use AI-powered models and a intuitive user interface to determine if there are malicious URLs on a web page. And if there are malicious URLs, providing the users with a confidence score based on an ML model, how confident the user can be if this URL is phishing or not, or safe or not. The way it works is three main components to the application. There is the Chrome extension. The Chrome extension is where you would see the URLs on the page. It scans the page for the URLs. Then it would take that information and pass it to a React front end. Then the React front end will take that URL, pass it back to a hosted microservice, a Python microservice that would take the URL as an input, pass it to the model, and from the model, the confidence score that is generated, that is passed back to the front end as a response to display the results of how confident we are if this URL is phishing or not. This is the main idea. These are the three core components: a Chrome extension, a React application, and then a Python backend. This is the project in concept, and in words, I will turn it over to Ali and Aduvu to show us how it works in action.
Hi, I'm Ali, and I will show you how our front-end, back-end, and Google Chrome extension work together to achieve our project's goal. So our project is built using three components. One is a React front-end that is the main front-end and the main application that shows the front-end page and asks the user to prompt a URL and returns the result whether it's phishing or not. Our backend is made using Django. Here we can see that it's running on 8,000 port. We are running the Django locally. Our React app is running locally. We have already also deployed it on Vercel. So for this demo, I will use the Vercel version. And here's the code for the Google Chrome extension, which is written in simple JavaScript and HTML. So let's start with the demo. So this is the front end of our, let's refresh it. We can see that it's deployed on Vercel app, the front end. This is the front end. We can write a URL here and click on the analyze button, and it will tell us whether the URL is phishing or not. So let's test with some sample examples. I've written some safe and phishing URLs. Let's copy them and let's test them on our app. So let's try this one. This URL appears safe because it has HTTPS and it's a legitimate URL. Let's try another one. So we can see this one is also safe with 99.61 confidence. Let's try Wikipedia. So this one has a different, like instead of .com, it has .org. Let's try this one. It also appears safe because it has HTTPS. Let's try a different one. These are some of the phishing URLs. We can see these don't have HTTPS and they look a little different. We can see that it's phishing URL detected. Let's try another one. And to test, we can also remove this part and then test. Let's see if it can detect without HTTPS and HTTP. Yeah, it can. So we can see that it's also detected. And the last one. So it's also detected. We can see that confidence is sometimes 0, sometimes 100. It depends on how well the model thinks this one is accurate or not. Artificial neural networks gives a probability between 0 and 1. And so we make a threshold around zero point 0.5 and then convert it to percentage. So let's try, or this was the front end application with the backend. Now let's test our a Google Chrome extension. So we have loaded our extension here in Google Chrome using this load unpack function. So this is the folder and we can select it. We can see that extension is loaded. Now we can go to this Google page where I've already searched Fansha. Let's refresh it. So it has, let's try our extension now. So here is the extension PhishGuard AI. It will uh, find all the your anchor tags in this web page and list them. So we just use the domain name because our model is trained on just the domains. So it sees the domains and tells whether a URL is phishing or not. We can click on this URL and it will open our app and tell us whether the URL is phishing or not. So since this is a Google page, most of the URLs here are legitimate, so we will not find any harmful websites here. Let's try another one. Let's see, fansha.ca. We can see that this URL also appears safe. So this was the complete demo. Now Heidi will explain the high-level implementation of the front end and browser extension.
Hi, my name is Idowu, and I'll be taking you through how the Chrome extension was implemented and how it's able to communicate with the front end. So, what basically happens behind the scene is, okay, first of all, the Chrome extension is a browser action extension. So it basically performs some processing in background on load of some pages. So when you have the extension installed and you visit a page like Ali visited Google website, what it basically does is the Chrome extension, we pull all the anchor tags on that particular page. Whatever website you're visiting is going to pull all the anchor tags and is going to process all the href attribute of those anchor tags. And Ali, can you go to the financial Google search? Yeah, you can do a refresh. And so it's basically going to pull all the anchor tags and retrieve all the href and process them and also list them on this pop-up. And right from here, the extension has a way of communicating with our front end that was deployed on Vercel. It basically sends the particular URL that the user clicks here. It sends it to the Vercel front end. Can you click on any URL? And okay, yeah, just click on anyone. Yeah, thank you. So, and yeah, if you look at the web browser, if you look at the web address input, you will see that there is a route parameter there. That is what the Chrome extension uses to communicate with the front end. It passes the URL that is clicked by the user. It adds it to the web address as a query parameter. And what the front end does is it searches the URL if there is any route parameter that is called URL, and it basically picks it up, adds it to this input, and it programmatically clicks on the analyze button for the back end to analyze the URL using the model. And that is basically how the front end, the Chrome extension works, and that is basically how it's connected to the front end. And I will hand it over to Tazinda to take you through some technical issues we had when we were implementing the project.
Thank you, Adu. Hi, Professor. So in this project, we have accomplishment all of these, and the first one is the training the artificial neural network model, and we have successfully trained this model to determine a confidence score of a URL, which is getting from the all the page, from the Google page. And after that, we have deployed the full stack of the application, and we deployed model as a microservice on the Amazon Web Services and deployed the front end on the Vercel. And the third one is the extension in a Chrome. And after that, we have GitHub collaboration. We use the GitHub organization to house all these three repositories that store the codes for the model and the front end and for the Chrome extension. After after this, we have integrated the front end, back end, and the browser extension for the seamless transitioning between the all of the three because we only want that user can easily access all of this the application without any hassle. And the last, and we stick to the our product roadmap, which we implemented on the first presentation, and that was created at the start of the project. So yeah, this was the holding, and I would hand over to the Mohammed. Over to you, Mohammed. Thank you.
Thank you, Tejinder. We ran into some technical issues as well. The first of them being the data quality and availability. We used a pretty rich data set. However, the domain here is a vast domain as phishing attacks continue to evolve, and the data set can very quickly go out of fashion. It could go obsolete very fast, given the evolving nature of phishing attacks and cybersecurity attacks in general. So you need a large and diverse data set and continually evolving data set to be able to train these models effectively. And acquiring these data sets and maintaining such data sets is quite a challenge. So that was a technical issue that we encountered. Another one that we encountered was that the model that we trained was could perform really well, and in fact did perform really well on training data, but on unseen data it didn't perform so well. Again, because the unseen data keeps evolving, the nature of phishing attacks keep changing, and that makes it difficult for the model to, in essence, keep up, and it requires strategies of more robust training and more access to a diverse data set. The last problem that we faced was that our model that we trained and was ready, that one that we fine-tuned, it was too large to deploy. After we went through a series of training and tuning of the model, and when we finally arrived at a model that we were happy with, that model was 1.5 gigabytes, even more, in fact, over 1.5 gigabytes. And that is a very big model to deploy anywhere on any website or any service on Render or AWS without paying exorbitant fees. And we chose to deploy a substandard version of our model to AWS, again, keeping our free tier privileges. And then we had to run the model locally, the final model, for the purposes of our demo and our testing and whatnot. These were the challenges and technical issues that we faced. Some of this we overcame with some mitigation strategies. Others are just problems that are by nature a problem in the cybersecurity domain, and we will continue to learn and adapt these techniques into our future projects. We thoroughly enjoyed working on this. This was a great learning experience for us. We were able to get our hands in all types of domains, in the deployment, in integration, in testing, in figuring out how to solve a real world problem, like take a phishing URL or sequence of URLs and figure out which one is safe and which one is not. It was a very fun project for us, and we are happy with the end result. This is all for our presentation. Thank you very much for watching, and I hope that you will be clicking on our site to see it in action yourself.